Hi, in this video we are going to talk about HashMap in Java. We are going to need this container for solving many problems on hashing. We also talked about one more container which was HashSet. HashSet is used to store only keys. However, this HashMap is used to store key value pairs. So when you have only keys, you can use HashSet. When you have key value pairs, you can use HashMap. Let's see the working of this with this example. So this is how we create a HashMap. The first type is type of the key. The second type is type of the value. We create a new instance using this syntax. I have used empty constructor here, constructor with empty parameters. There are more ways of creating HashMap. You can specify initial capacity that can be used by your compiler or interpreter to optimize the implementation. There is a constructor to specify the load factor also. There is a constructor to create a HashMap from other HashMap. But all the other constructors we rarely use. We mainly use this one and the one that specifies the initial capacity. If I know that this HashMap is going to store n elements of an array, I can use that constructor. Okay, so we created a HashMap. Now we put some items. So these items are actually key value pairs. So there are two parameters in this function, key and value, key and value, key and value. So what happens? This creates a HashMap with three key value pairs. Now if I print this HashMap, what will I get? I will get all the three key value pairs, GFG equal to 10, comma, IDE equal to 15, comma, courses equal to 20. That's what I'll get when I print the HashMap here. There are many functions in HashMap. One of them is size, that tells you the size of the HashMap, how many key value pairs are there. So you will get 3. And this is how you traverse the HashMap. Suppose you want to traverse the HashMap, you want to do certain operations with all the keys or all the values, you can do this using this traversal. So we use map.entry, which is type of an entry in the HashMap, and we get all the key value pairs using m.entrySet. Please remember, HashMap implements map interface, right? There are other collections also that implement map interface, like TreeMap is the one, but HashMap is the one that uses hashing and implements the map interface. Map interface means key value pairs. Set interface means only keys. So this is where we traverse the HashMap and print all the key value pairs one by one. Here I have used it for printing. We can use it for any purpose. Traversal is useful in many places. So I'll print GFG 10, then I'll print IDE 15. Please remember the output order here and here. It can be any order. You know, there is no prediction about the order of these elements because it's hashing and different keys may go into slots in any order. So there is no particular order in which you will get the output. You may get courses first, you may get courses here. So here also I've written the same order though, but you may get different order. Let us now talk about more functions of HashMap. Contains key. It is used to check whether a key is present in the HashMap or not. This is one of the most used functions when you use HashMap to solve coding problems. Next function is remove. This function is used to remove a given key from the HashMap. This will remove IDE from the HashMap with 3 key value pairs. If you call contains key after this remove, you will get not found, right? No in the output. You will go in the else part because contains key will return false now after removal, right? So what is the output of this program? Since we have called contains key before remove, we'll get the output as yes. Then it will remove IDE. So what will be the size of new HashMap after removing one key value pair? You will get the output as 2. Initially it was 3, now you get 2. So remove function removes a key, contains key function is used to check whether the key is present or not present. One important thing about the remove function, it returns the value corresponding to the key. So if you have removed IDE, the value 15 is returned by the remove function. And if the key is not present in the hash map, then it returns null. Let us now talk about more functions. Contains value is used to check whether a given value is present in the hash map or not. So I have passed 15 here. 15 is present in the hash map as a value, so it will return true. If I pass a value which is not present in the hash map, then it will return false. So the output is going to be yes. Let's talk about one more function, get, which is used to get a value corresponding to a given key. If I pass a key which is present in the hash map, then it will return the corresponding value. So I'll get 15 here. Because I passed IDE, corresponding value is 15. If I pass a key which is not present in the hash map, then it will return null. So the output that I'll get here is null. So I've talked about main functions on HashMap. Let's quickly talk about the time complexities. Functions like put, contains key, remove are big O of 1 on average because they use hashing. Functions like get are also big O of 1. Functions like size, is empty are big O of 1 even in worst case. So hashing is a data structure, hash map is a data structure or collection which provides most of the operations in big O of 1 time. Certain operations are big O of 1 on average and certain operations are big O of 1 in worst case.